Okay, so starting with the new topic, that is deadlock. Okay, this is a very important topic, and this question has been asked in examination, that is Mumbai University examination. And we can rate this question. We can rate this question as a 3 star because this is very important question. Okay, so just okay, we'll try to understand the concept of deadlock. Okay, so imagine, first of all, imagine that we are having set of processes. Okay, so whenever we are defining set of processes, then we can define in this way: p1, p2, p3 up to pn. Okay, so these are the set of processes which exist. Okay, and then if some process is holding any resource, if any process is holding any resource, then we can represent in this way. For example, this is the process p1 and this is the resource r1. Okay, so process p1 is having the resource r1. How we can represent? We can represent is with the arrow mark. Okay, so arrow mark is toward the process. Okay, so now we can see that this process is holding the resource r1. Okay, or the resource r1 is being held by the process p1. Okay, if we want the resource r2, okay, see, just I will imagine the second way, that is resource r2. If p1 is having a requirement, if p1 is having a requirement of r2, then it can be shown like this. Okay, so p1 is having the requirement of r2, but right now it is not having a control of resource r2. Okay, so we have to show the arrow mark towards the resource. Okay, so this is just a simple convention we need to understand first before understanding the deadlock. Okay, so this is the arrow. This is arrow which indicate that p1 hold the resource r1, and this arrow mark indicate that it has the requirement. Okay, so requirement. Okay, now you can clearly understand p1 is having a requirement of r2 and p1 is having the hold of resource r1. Okay, so this is the just a basic concept. Okay, now we'll try to understand the concept of deadlock. When a set of processes wait for some resources which are held by some other process within the set, this condition is called as deadlock. Okay, let us understand how this happens. Okay, so imagine this is the process p1. Okay, this is the process p2. Okay, p1 is having the resource, p1 is having the resource r1. Okay, so I will draw the r1 over here. Okay, so p1 is having resource r1. Okay, so p1 is having resource r1 and p2 is having resource r2. So p2 is having resource r2. Okay, now p1 has a requirement of r2, p1 has a requirement of r2, and p2 has a requirement of r1. Now the situation is like that p1 is having the hold of r1 and has a requirement of r2, p2 is holding r2 and have a requirement of r1. Okay, it will not release the r2, that is p2 will not release r2 until and unless it will gain the hold of r1. Okay, जब तक r1 मिलेगा नहीं तब तक ये r2 छोड़ेगा नहीं. And p1 hold the resource r1 and has a requirement of r2. Okay, so p1 r1 को रिलीज नहीं करेगा जब तक कि उसको r2 मिलेगा नहीं. ओके, सो सम काइंड ऑफ सिचुएशन जैसी जो आती है, इस सिचुएशन को हम लोग बोल सकते हैं कि ये सिचुएशन अब हो गई है डेड लॉक्स. ओके, we can take more example like the two trains are coming. Okay, this is the one train. Okay, and this is the second train. Okay, and this is the same track. Okay, you can just imagine this is the same track. Okay, and both the trains are coming heading towards each other. Okay, so एक ट्रेन, ये आपकी ट्रेन 1 इधर आ रही है, ये ट्रेन 2 इधर है, इसका डायरेक्शन इधर है, इसका डायरेक्शन इधर है. ठीक है, सो एंड दोनों के दोनों एक ही ट्रैक पर हैं. So we can't see both the trains because both are coming towards each other. So this condition can also be termed as the deadlock situation. Okay, okay, so now let us understand this deadlock in more detail. Okay, deadlock. Okay, so just now we have seen the concept behind it. Okay, when set of processes wait for some resources, when set of processes wait for some resources, wait for some resources which are held, which are held by some other processes within the set, within the set. We have seen the set, that is p1, p2, p3. Okay, it may goes to pn. So this is the set of process. Okay, so if any process hold the control of any resource, okay, which is being required by any other process, okay, then we can say that it is the deadlock. Okay, and we have seen the examples also. We will see one more example. Okay, let us come, we'll see one more example. This is the road. Okay, in which way it is the road consists of two lanes. Okay, we'll understand this is the two lane road. Okay, this is the two lane road. Okay, one vehicle is coming from here. Okay, one vehicle is coming from here, one is coming from here, and one is coming from here. Okay, so this is the situation where they can right now this is a situation they can hold and they can save the deadlock condition. But if they will not care for it and they will go ahead, then surely the deadlock will occur. How it is possible? The His vehicle wants to go straight, this wants to go straight, this wants to go straight, and this wants to go straight. Now look at the situation. Okay, if it comes ahead, when all will not take care of each other and will come closer, then what will happen? This will come over here, this will come over here, it will come over here, and it will come over here. Okay, so no one wants to go back, no one wants to go back, and all are now close to each other. Okay, अभी एक को भी अगर निकलना है तो उनको पीछे जाना पड़ेगा, बट दे विल नॉट. ओके, तो श्योरली दिस इज द डेडलॉक कंडीशन. ओके, जस्ट एन एग्जाम्पल. ओके.